for this session. And a coin is just a little bit of a token. My name is Russ Smith. I'm Technical Director at Zscaler. And with me is Conrad Maiorino. He's one of our sales engineers. And the way we've structured this presentation is I've got some topic, sort of zero trust focused information to pass on, a slightly different way to look at zero trust, and then we're going to go into some more specifics around the zero trust architecture that Zscaler provides. So it's and with that we have a demo that we'd like for you to participate in if you'd like to, and it just ties in with a use case that we're going to finish up the presentation on around JADC2 and how you can enable zero trust to rapidly onboard coalition partners and get them zero trust access to mission critical applications. So we'll do that towards the end and get a little bit of audience participation in that, just really filling out an email to some extent there. But again, my name is Russ Smith. I'm a technical director at Zscaler. Spent 30 years in the Air Force. I retired in 2016. And I've been really focused on zero trust ever since I retired. And this particular presentation has evolved primarily because the beans, bullets, and bytes, other than being a kind of a cool alliteration around the letter B, is meant to think of zero trust from a logistical challenge. So getting beans and bullets to the front lines is as critical as getting information to the front line, and that's where that idea of bytes comes in. So realizing the promise of zero trust is really that enabler to get that critical information to the front line. As I mentioned, this is an opportunity for you to participate in a little bit of a demo. If you'd like to, you can just go ahead and hit this QR code, and what will pop up is a pre-formatted email. You can go in there and put your name and an email address in. The intent of this is to just show you how quickly we can get you from zero access to zero trust access just in the course of this presentation. And Conrad's going to go in, as he walks you through the architecture, he's going to walk you through exactly what's happening within the backside here of the architecture to get you that access. So in talking through beans, bullets, and bytes, there's an idea around lines of communication. When you think about it as a logistics challenge, there's a lot of, within the military operational art, written about lines of communication as a way to supply the front lines with critical resources. And so we're gonna talk through exactly what that means in today's cyber domain and how you can better support the warfighter. And then we'll go into a use case around agile combat employment. This is today's near-peer challenge. I'm going to kind of walk you through real quick about how zero trust really enables that ability to get the information up to the front line. And then we'll go into a little more detail on what it means in the cyber domain to establish those lines of communication with zero trust, and then wrap up, as I mentioned, with that JADC2 use case and demo. And what you're going to find is that automation is critical to being successful today. And this ability for us with just an email to establish zero trust access in an automated fashion is what the warfighter needs to be agile today. So every good cybersecurity presentation starts off with this guy. For those of you that may have spent some time in military professional education, you recognize this is Karl von Clausewitz. And he followed Napoleon around in the early 19th century. And he talked about these lines of communication that are necessary for an army to move and defeat the enemy. And what was interesting about that is that whole theory behind lines of communication is something that we have held on to, and in every domain of warfare, there's this notion of how do I secure lines of communication to support warfighters. You see that in this picture. This is the Navy. It's probably a World War II era picture, but it gives you the vision of the Navy crossing the ocean, and they cannot secure the entire Atlantic Ocean. They can only carve out their piece of that line of communication, and and secure that one slice of the domain that they're responsible for. The Air Force does the same thing. As we're flowing forces into Afghanistan, we leave the confines of CONUS bases and flying to a place like Manas Air Base in Kyrgyzstan and then on to Bagram Airfield in Afghanistan. These are that notion of lines of communication where we don't own all of the domain, but you have to be able to operate within that domain. You have to do it securely. And where do we see that failing for the enemy? You look at Desert Storm. The Army was able to cut off the lines of communication of Iraqi forces in Kuwait, and this was the famous left hook that Schwarzkopf had briefed. I like to bring this up from my Army friends because they think Desert Storm was only fought from February 24th to February 28th, 1991. But for the Air Force people, you know that there was like 100 days of air power that was inflicted on the Iraqis prior to the 100 hours that the Army actually involved. So let's talk a little bit about cyberspace as a domain. This is General Larry Welch, and he was the Chief of Staff of the Air Force in the late 90s. Early 90s, late 80s. And he talked in 2011, he did a lot of sort of thought leadership around cyberspace as a domain. The department was trying, just like they are today, kind of trying to figure out exactly where cyberspace fits and how is it in relation to the other domains of warfare. And what he did was he kind of laid out from a domain perspective, what do each of the services have to do to be successful in their own domain? You know, I got to pause just for a second. I just remembered I didn't do the announcement. So let me pause real quick. For those of you that are getting the CEU credits for this, at 4:25, that little scanner, I guess, is going to fire up. And then you'll be able to go ahead when this is over and scan that. So please make sure that if you're looking for CEU credit, that you scan the little reader in that. So back to General Welch. So he was talking about exactly what it takes to be successful in each domain of warfare. And he said there are certain things that you have to be able to accomplish within each domain. He talked about passive defense, he talked about active defense, some kind of intel prep of the battlefield, some way of attacking the enemy in the domain. There's a critical role that defining capabilities and developing those systems plays in each domain. And then finally, when he talked about cyberspace, he says it's unique in the sense that cyber is the only domain of warfare that you're actually constructing. You can build it yourself. And then he said that, but he also cautioned folks to say, but you should not fall into the trap of thinking, in order to operate successfully within the domain, you have to construct the entire domain. So it almost goes back to that notion that that picture of the Navy vessels transiting the ocean, where you may not be able to own everything within that domain, but you have to identify a way to carve out and securely transit the domain that you're operating in. You have to do that without trying to own the entire domain. And so I would coin a term here, cyber lines of communication. That's operating within cyberspace and establishing critical lines of communication. And how do you do that? We do that because Zero Trust has become an enabler for us to carve out that piece that we have to operate within securely. So what is Zero Trust? This is, for those of you that are kind of following a lot of the discussions around Zero Trust, it has been around for a long time. The notion of how do I operate my ability for users to access information when those users are leaving the enterprise boundary. Prior to Zero Trust, we secure the perimeter, we put up firewalls of the enterprise architecture. In 2018 or so, you had NIST come out with the Zero Trust architecture. So some of you may be familiar with NIST SP 800-207, which defined what a Zero Trust architecture looks like. And this is coming right out of the pub. So if you want to get into more details on NIST's view of Zero Trust, it's in that document 800-207. And the salient features of what a zero trust architecture is, it really comes down to, you have a cursor here, this inside this oval here where you have policy decision making and policy enforcement happening with every connection from the user to whatever resource that they're trying to get access to. So nowhere do you see the protections of firewalls preventing adversaries from getting into a network. It is really all about a user, or in this case, they call it a subject, getting access to an enterprise resource. And there's some way of establishing policy decisions, and then there's a way to enforce those policies, to either allow access or to block access. And that's really kind of as simple as it gets. But it's complex because we need a lot of really important context in order to make those policy decisions. And around the outside of the oval, you see continuous diagnostics and monitoring, industry compliance plays a huge role, threat intel, understanding exactly what the adversary is doing and how they are maybe obfuscating their own ability to get inside of the enterprise boundary. Shout out to the Security Operations Center folks who are out there with their activity logs and being able to monitor traffic. Data access policy, your IDAM solution, SIM for looking at individual event monitoring. All of those are critical. They all fall under the category of context that allows the individual to make decisions, with the corporation or the organization to make decisions on whether or not a user should be able to access a resource. So to summarize, you've got all this context that's feeding inside of that decision making from a policy decision making and as well as policy enforcement. But how do you do that? You do that by you have to terminate the connection. So now we're going to start getting into kind of more of the zero trust architecture itself. It's critical to terminate the connection. And the reason why you have to terminate that connection is you have to understand exactly what is in that pipe where the bytes are starting to flow. And you can't do that if you can't open up and inspect exactly what's in that transmission area, transmission pipe. So you're inspecting the data, you're identifying the source, you're determining the destination. You have to verify the user, you have to verify the data, you have to understand the threats that are associated with that connection. And then you have to compare the user's desires for accessing resources against the policies that have been established on granting access or denying access. And then finally, you have to broker the connection. You have to monitor it. You have to ensure that if anything changes within policy, you're able to rapidly terminate that connection. So really, this is what zero trust is. It's the ability to terminate a connection, inspect all the traffic that's going through, make a decision around policy, whether that individual is allowed access or not, and then establish and monitor that connection. So the DoD then came out recently with their DoD Zero Trust Principles. And this has been a really good way to view zero trust and the implementation of zero trust and all of the tools that are out there right now that are claiming to provide zero trust. You kind of start to think through, where does this fit in within the zero trust principles as defined in the DoD reference architecture? And this comes directly out of the DoD reference architecture. So principle number one is assume no implicit or explicit trusted zone in networks. So as I was saying before, zero trust is really solving that challenge of my users have left the enterprise boundary and they're connecting to resources that are probably not inside of the corporate boundary or inside the organizational boundary at a base, post, camp, or station. They're probably in the cloud. And so if I've got an end user that's dialing in from home or from a Starbucks and they're accessing resources that are in the cloud, I cannot have an assumption around a network that I can transit all that traffic through in order to secure it. Principle number two is identity. So all person entities need to have an identity. And that identity is used to determine whether or not they have the right credentials in order to access the resource they're trying to access. Principle number 3 is around non-person entities. So just like a person entity accessing a resource, principle number 3 says you're going to have communications that you need to manage in a zero trust manner that are non-person entity communicating with a non-person entity. Think IoT devices, think workloads, securing your CI/CD pipeline, those kinds of things. You have to have a zero trust way of doing that. And there may not be a person involved that has a PIV card in order to do that. Principle number 4 talks about risk profiles. And what's critical here is that it's not always black and white as to whether or not an individual should be able to access a resource. Maybe something in the gray zone. And that could be defined as, well, the person has put in the correct password. Maybe they've passed whatever biometric checks I have from a multi-factor authentication perspective. But they're showing up at a place that I've never seen them show up before. So their risk score may go down, and it's critical in a zero trust perspective to be able to recognize it's not black and white. It may fall into a gray zone, and I may want to grant them some kind of conditional access, and I may want to hold them off maybe in some kind of a cloud browser isolation mode, let's say, and not allow them access to the data, the actual data, but I may let them see a picture of the data, so they can't download it, they can't cut and paste, but they can still see it until I'm confident that this person is who they say they are. All sensitive data is encrypted both in transit and rest. That comes right out of 800-207. All transmission has to be encrypted. Principle number 6 talks about monitoring traffic. You have to have some way of making real-time decisions around connectivity because things can change. And when they do change, you have to have some way of disconnecting that connection because there's a violation of some sort of policy. And then finally, principle number 7 talks in terms of policy management and distribution. A lot of tools that are in a zero trust architecture can do some level of policy enforcement. But if you've got conflicting policies that are being established, you're really going to have a lot of trouble enforcing a true zero trust architecture. So from a DoD perspective, there's got to be some way of centralizing that so you can manage all that policy access. Okay, so let's shift gears just a little bit and talk in terms of agile combat employment. So General C.Q. Brown fleets up. He was the Air Force Chief of Staff, he's now the Chairman of the Joint Chiefs, of course. And he talked a lot about this. In this theater in particular, this is particularly important. And the idea here is that if you are going to move forces around the battlefield, you have to have a way of rapidly, in an agile manner, be able to establish connectivity. The way we typically do that is you stack pallets of gear on C-17s and you fly them out to forward operating bases and forward operating stations with the intent of establishing different remote locations where you can execute missions from. That requires a lot of gear. And once that gear is set up on at the location, at the forward location, some of the soldiers, sailors, airmen, and Marines may not have seen that gear for a while because they packed it up quite a few weeks before, maybe a month before, and now they have to unpack it in that forward location. First thing they're doing is they're having to patch all that equipment, bring it into compliance before they can bring it up onto the network. And you start to see these individual lines of communications being established. Ideally, you're working in an environment which is the exact direction that the DoD is going in, where we're relying more on cloud-based resources. So these forward operators are not having to do all this patching to bring these forward operating locations up into compliance and ready to execute the mission. So now if you're communicating with the cloud, you can bring a lot less gear forward and you can connect directly up. So the only way you're going to be able to do this is in a zero trust manner, because tromboning out or hairpinning out, whatever word you want to use, from the forward location back to a corporate enterprise or an organizational enterprise, in order to get to cloud resources, it creates a tremendous amount of latency, and typically it's a pretty awful user experience. So how do you more rapidly get connectivity from those forward operating locations to the cloud? And you do that in a zero trust manner. And the benefit of that is that as non-Air Force, Army, Navy, U.S. forces are starting to integrate with coalition partners, now you can identify a way of rapidly getting those coalition partners access to the critical resources they need. And you're not doing it in a way. My ability for users to access information when those users are leaving the enterprise boundary. Prior to Zero Trust, we secured the perimeter, we put up firewalls, we put all of our crown jewels, all of our applications, all of our data inside of an enterprise boundary, and then we secured access into that enterprise. What Zero Trust really recognized, and where the term was coined by John Kindervag in around the 2011 timeframe, what he was saying was the enemy has already gotten inside of those enterprise boundaries, and we're no longer able to keep the enemy out. So we cannot trust, just because you have gotten inside of the enterprise boundary, we can't trust you. The enemy is able to move laterally within the enterprise, and we have to figure out a way to verify all transactions, whether you're coming from outside or you're inside of the enterprise architecture. In 2018 or so, you had NIST come out with the Zero Trust architecture. So some of you may be familiar with NIST SP 800-207, which defined what a Zero Trust architecture looks like. And this is coming right out of the pub. So if you want to get into more details on NIST's view of Zero Trust, it's in that document 800-207. And the salient features of what a Zero Trust architecture is, it really comes down to, I do have a cursor here, this inside this oval here where you have policy decision making and policy enforcement happening with every connection from the user to whatever resource that they're trying to get access to. So nowhere do you see the protections of firewalls preventing adversaries from getting into a network. It is really all about a user, or in this case, they call it a subject, enforce those policies to either allow access or to block access. And that's really kind of as simple as it gets. But it's complex because we need a lot of really important context in order to make those policy decisions. And around the outside of the oval, you see continuous diagnostics and monitoring, industry compliance plays a huge role, threat intel, understanding exactly what the adversary is doing and how they are maybe obfuscating their own ability to get inside of the enterprise boundary. Shout out to the Security Operations Center folks who are out there with their activity logs and being able to monitor traffic. Data access policy, your IDAM solution, SIM for looking at individual event monitoring. All of those are critical, and they all fall under the category of context that allows the individual to make decisions, the corporation or the organization to make decisions on whether or not a user should be able to access a resource. So to summarize, you've got all this context that's feeding inside of that decision making from a policy decision making and as well as policy enforcement. But how do you do that? You do that by, you have to terminate the connection. So now we're going to start getting into kind of more of the Zero Trust architecture itself. It's critical to terminate the connection. And the reason why you have to terminate that connection is you have to understand exactly what is in that pipe where the bytes are starting to flow. And you can't do that if you can't open up and inspect exactly what's in that transmission area, transmission pipe. So you're inspecting the data, you're identifying the source, you're determining the destination. You have to verify the user, you have to verify the data, you have to understand the threats that are associated with that connection. And then you have to compare the user's desires for accessing resources against the policies that have been established on granting access or denying access. And then finally, you have to broker the connection. You have to monitor it. You have to ensure that if anything changes within policy, you're able to rapidly terminate that connection. So really, this is what Zero Trust is. It's the ability to terminate a connection, inspect all the traffic that's going through, make a decision around policy, whether that individual is allowed access or not, and then establish and monitor that connection. So the DoD then came out recently with their DoD Zero Trust principles. And this has been a really good way to view Zero Trust and the implementation of Zero Trust and all of the tools that are out there right now that are claiming to provide Zero Trust. So you can kind of start to think through, well, where does this fit in within the Zero Trust principles as defined in the DoD reference architecture? And this comes directly out of the DoD reference architecture. So principle number 1 is assume no implicit or explicit trusted zone in networks. So as I was saying before, Zero Trust is really solving that challenge of my users have left the enterprise boundary and they're connecting to resources that are probably not inside of the corporate boundary or inside the organizational boundary at a base, post, camp, or station. They're probably in the cloud. And so if I've got an end user that's dialing in from home or from a Starbucks and they're accessing resources that are in the cloud, I cannot have an assumption around a network that I can transit all that traffic through in order to secure it. Principle number 2 is identity. So all person entities need to have an identity. And that identity is used to determine whether or not they have the right credentials in order to access the resource that they're trying to access. Principle number 3 is around non-person entities. So just like a person entity accessing a resource, principle number 3 says you're going to have communications that you need to manage in a zero trust manner that are a non-person entity communicating with a non-person entity. Think IoT devices, think workloads, securing your CI/CD pipeline, those kinds of things. You have to have a zero trust way of doing that. And there may not be a person involved that has a PIV card in order to do that. Principle number 4 talks about risk profiles. And what's critical here is that it's not always black and white as to whether or not an individual should be able to access a resource. There may be something in the gray zone. And that could be defined as, well, the person has put in the correct password. Maybe they've passed whatever biometric checks I have from a multi-factor authentication perspective, but they're showing up in a place that I've never seen them show up before. So their risk score may go down, and it's critical in a zero trust perspective to be able to recognize it's not black and white. It may fall into a gray zone, and I may want to grant them some kind of conditional access, and I may want to hold them off in maybe in some kind of a cloud browser isolation mode, let's say, and not allow them access to the data, the actual data, but I may let them see a picture of the data. So they can't download it, they can't cut and paste, but they can still see it until I'm confident that this person is who they say they are. All sensitive data is encrypted both in transit at rest. That comes right out of 800-207. All transmission has to be encrypted. Principle number 6 talks about monitoring traffic. Have to have some way of making real-time decisions around connectivity because things can change. And when they do change, you have to have some way of disconnecting that connection because there's a violation of some sort of policy. And then finally, principle number 7 talks in terms of policy management and distribution. A lot of tools that are in a zero trust architecture can do some level of policy enforcement. But if you've got conflicting policies that are being established, you're really going to have a lot of trouble enforcing a true zero trust architecture. So from a DoD perspective, there's got to be some way of centralizing that so you can manage all that policy access. Okay, so let's shift gears just a little bit and talk in terms of agile combat employment. So General C.Q. Brown fleets up. He was the Air Force Chief of Staff. He's now the Chairman of the Joint Chiefs, of course. And he talked a lot about this. And in this theater in particular, this is particularly important. And the idea here is that if you are going to move forces around the battlefield, you have to have a way of rapidly, in an agile manner, be able to establish connectivity. The way we typically do that is you stack pallets of gear on C-17s and you fly them out to forward operating bases and forward operating stations. with the intent of establishing different remote locations where you can execute missions from. That requires a lot of gear, and once that gear is set up on at the location, at the forward location, some of the soldiers, sailors, airmen, and Marines may not have seen that gear for a while because they packed it up quite a few weeks before, maybe a month before, and now they have to unpack it in that forward location. First thing they're doing is they're having to patch all that equipment, bring it into compliance before they can bring it up onto the network. And you start to see these individual lines of communications being established here. Ideally, you're working in an environment which is the exact direction that the DoD is going in, where we're relying more on cloud-based resources. So these forward operators are not having to do all this patching to bring these forward operating locations up into compliance and ready to execute the mission. So now if you're communicating over the cloud, you can bring a lot less gear forward and you can connect directly up. So the only way you're going to be able to do this is in a zero trust manner, because tromboning out or hairpinning out, whatever word you want to use, from the forward location back to a corporate enterprise or an organizational enterprise in order to get to cloud resources creates a tremendous amount of latency, and typically it's a pretty awful user experience. So how do you more rapidly get connectivity from those forward operating locations to the cloud? And you do that in a zero trust manner. And the benefit of that is that as non-Air Force, Army, Navy, U.S. forces are starting to integrate with coalition partners, now you can identify a way of rapidly getting those coalition partners access to the critical resources they need. And you're not doing it in a way that we've been doing it in the past, which is to establish Afghan Mission Network as an example, a coalition network that's specifically built for a particular contingency. What you want to do is you want to be able to rapidly form up these coalition integrated teams and get them the access that they need to the data that they need in order to execute the mission. And you can't do that if you're building complex networks with a lot of equipment going forward. Okay, so before I get off the stage, I'm going to hand it over to Conrad to walk you through more on the architecture itself, just to kind of summarize from a Zscaler perspective how we're going to do the establishment of cyber lines of communication. It starts with a user. That user has a device. That user has an identity. At the far end, that user with that identity is trying to access a resource. What Zscaler will do is put what we call a client connector on the user device. And that client connector acts as a policy decision point. At the distant end, at the application or the resource that the user is trying to get access to, we're going to install an application connector. And that application connector acts as a policy decision point at the distant end. And that application connector is only communicating one way. And it's communicating to a private access broker or controller that is acting as a policy decision point. Excuse me. The app connector and the client connector are policy enforcement points, which would terminate the connection if needed. And the decision making is happening within the broker. One-way connectivity from the app connector to the broker. If you're reachable, you're breachable. If you don't see the IP address of the application and that application is only communicating in one direction, the adversary cannot get to the application. The application goes completely dark. On the other end, the client connector registers its location and makes a request to get connectivity to the application. Policy decision making then is done within the broker. And right here at step 5, you see what is a cyber line of communication over any transport mechanism. And this is really critical. So we've got fielded forces that are going into maybe a location that's not so friendly to U.S. forces being there. It's not going to be a problem from a zero trust perspective because I'm riding over that transport and I'm not relying on that transport to provide me security. All that security is happening between the client connector and the app connector, And the broker then is making that encrypted connection from the user to the application. And then this just kind of summarize the location of the policy decision-making, the policy enforcement, and exactly how we're hiding the location of the application and preventing an adversary from getting to it. Everybody's yours. You got the clicker? Right down. Just.
Oh. Thanks for being here. I'm Conrad Maiorino. And this is an attack surface that's anything that's out there where this tool does public inquiries on everything that's out there, and there's never any traffic sent into your network or anything, and they're able to get this data at any given time. When Russ said before, when you're reachable, you're breachable, and that's the difference. For those of you who signed up for the what you call it, the demo, if you go to splunk.vpnkillers.net, and your email address is going to be your first dot last for some of you. One of you had an email address error, so I fixed it. But you should all be able to log into that right now, where we gave you access to the Splunk, and you can go and look at the data if you want. It's splunk.vpnkiller.net. That being said, so this thing working? Oh, I'm going the wrong way. With this here is, that's okay. What happens when AI and machine learning are going out, finding this, and writing the malware that's needed to break into that particular vulnerability you have because it's reachable, whether it's a VPN, whether it's a website, yeah, even a regular website has an open listener that says, knock, knock, who's there? It's my 0 day, let me in. That's the difference between Zscaler and everyone else. We do not have any open listener. It is a mutually authenticated certificate pin connection from this app, the app connector, to the broker. And if anyone even knew this IP address, it doesn't accept any inbound connections. It just gets dropped. The user here gets a 164 NAT carrier address. Even though this is a 10.10.7 in P1, C1, AWS, Azure, Google, it doesn't matter. You can have apps in all of them and be connected to all of them at the same time. It's not a VPN where you have to be put on a network. We're not putting you on a network. We're just giving you a tunnel to just that application. So I don't have to log off to one VPN to get on another to see that application. You can get to every single one of your apps. Doesn't matter where they're located. The user won't have no idea where they're located. CONUS, OCONUS, it doesn't matter. We just make a micro tunnel to that application in that moment of time. 0800, everything was good. 0915, some malware woke up on the endpoint, ran some commands, a zero trust score dropped, ULIS lost access to all real apps and data. And I say real because we're going to put you in a decoy network and let you run wild to do threat intelligence on you. That's Zscaler in a nutshell. Next. This is what it looks like. Very, very simply. Whether you're going to SaaS or internet, whether it's private apps in your data center, base camp, post station data centers, it doesn't matter. ITAS, PAS, C1, P1, it doesn't matter. What are we doing? First we're going to verify. Then we're going to control risk. Then we're going to enforce. And we do these things, I'll do layer by layer in a minute here. So the first thing is you have a connection, it gets severed. Just like any other proxy, it severs it. Then it says, hey, who are you? Where are you? Who's connecting? Is it an application, excuse me, is it a user? And what user, what device are you using? Is it a workload? Is it a battlefield thing? Is it a weapon? Is it a camera? Is it an IoT, BIoT? It doesn't matter, OT. From there, the next thing we do is now we understand it's Jane. She's multi-factor authenticated, and it's a GFE. Tom, he's in BYOD or BYOAD. We can have this data. The next step we do is, what are the rules and responsibility of this person? What mission do they belong to?
From there, we could say, what's that context? Now we know it's Tom. Tom's using a phone, the status is unknown, and he's off base. So maybe we're going to put him in isolation where he just gets read-only to that private app. Maybe it's manufacturing and it's located in factory A. We trust that. It's on a trusted network. We give them full rewrite access. The next thing we're going to do is, where is this connection going? What is the destination of the app criteria? Is it known? Unknown? Is it a newly discovered app? Once we have this data, we could start making more detailed decisions on what's going on with this connection. By the way, this is every packet in every session. Next. So now we understand it's Jane. She's going to P1. EPR, they're going to Azure. Manufacturing, it's doing C1. Logistics, it's in a base camp poster station data center. We can have this. And now we understand the destination. We could start to apply different kinds of security policy on it. Next, what is this? We have adaptive control. What makes this access risky? Sorry about that. Is it a user behavior that's something different? Did they accidentally just click on a zero-day phishing link, and I need to revoke their access to all apps and data until that endpoint gets scanned or whatever the security policy of your what you call it, your mission? Is the device posture good? Like I said before, 0800 things were good, 0915 malware woke up, your behavior is not good, we're going to deny you all apps and data, and a big thing comes on their screen, please call help desk, you just lost access to everything. Tell them Rule 17 of Zscaler just stopped you. Now they know exactly what to do. Now if I'd actually had some kind of machine learning or ServiceNow in there or something, I may not even need another person on the end of and I can all automate this. From there, I can look at if it's an API call that made the decision. Next, we're going to do, are you carrying anything bad in this packet? We want to prevent compromise here. Is it a blocked and known bad, something we've seen before? Zscaler currently does 330 billion transactions a day right now. A year ago, it was less than 200. But we keep growing and growing in size, and the rest of the world the commercial cloud feeds the IL2 cloud. All the data from the IL2 cloud and the commercial that's in the IL2 cloud feed the IL5 cloud. IL5 cloud doesn't share with anybody. IL2 cloud only shares with IL5, and so on. So we have all of this threat intel, and the transaction for us is, you go to OneDrive, you download a 10 meg file, that's one transaction. And we're doing over 330. If you go to trust.zscaler.us, you can see what we're doing at any given moment in time. From there, we want to talk about out of band. So if I have a OneDrive, like I just said, and someone puts something in there that they're not supposed to, I have to do that out of band scanning, not just inline. Next, what we're going to do is prevent data loss. Are you carrying stolen goods? We do this through data loss prevention, inline CASB, file type control. We can also do this with endpoint protection. From here, that is from inline. Out of band, again, we protect the CASB, this SaaS security posture management, CNAP. We could do vulnerability scanning, all done in this one cloud that does everything when you think about it. Every part of Zscaler is built in a container. So when we come out with a brand new way of doing something, it's just pushing another container to our OS. There's no racking, there's no stacking for that other feature. We're future-proofed. And when we do an update, we don't update everything, we just update the container whatever security thing we're doing. Everyone clear on that? That's a really important point. Think about that. A brand new technique, a brand new feature, all it is us pushing a container. Zscaler never writes anything to disk. Everything is done in memory. It's called single scan multi-action. It decrypts the packet, sends it into memory. Every single piece of security we do is done at the exact same time. Now you're thinking JRSS, IAP, they have security stacks, right? And you gotta just keep going up and up and up, and all that latency, all that redundant logs going into your SIMs. It's a guy sweeping the ocean when you're looking at data. So from there, the next thing we do is we now can enforce policy with all of this information we have. And everything we do is either conditional. You may have access in this moment of time, but behavior 5 minutes from now revokes your access. I don't call it zero trust. I call it dynamic need to know, because that's what happens. It's a dynamic need to know. I'm flying an airplane. I don't have the coordinates where the bomb needs to go. In 15 minutes, I'll know, because I'm close enough to get that information. Or if I'm doing something that I'm not supposed to be doing, I can revoke the access that I do have. From there, we can prioritize traffic. We can steer traffic. We can warn. Again, we can isolate. Not just isolate going to Facebook and going to SaaS applications, but isolate, hey, I have Elastic running. Elastic just released a 0-day. We can't patch it for 6 months. What do? Zscaler, you do isolation to just that application in a read-only. No uploads, no downloads, no cuts, no pastes. They could see the data they need to do their job. Done. From here, we can quarantine, we can deceive, like I said before, and then we can do a conditional block. Conditional block is, hey, you just did a continuous comply to connect, you didn't update your antivirus. A pop-up comes up, please right-click on your antivirus, and we can do a machine tunnel to its quarantine location for that GFE that they now can get healthy. Another pop-up comes up and says, try again now. Now they get access to their application without opening a support call. All it is through our network, our notification network. Very powerful at the fingertips. Make your users work for themselves. Self-service. And then and only then do we say we're ready to connect to apps, whether externally or internally, right? That application goes out to SaaS, and again, inside out, from wherever your private apps are to that app connector. How am I doing on time? And again, that's important. That connection is mutually authenticated, certificate pinned from the user to that app connector. Just like a type 1 encryptor, nobody can inspect it. If someone has a hold of the ISP, has a hold of the network, insider threat, and they're trying to look, the connection will be severed and the SIM will be alerted that happened. No data will ever be sent down a tunnel that someone's trying to tamper with it. The tunnel breaks and alerts all the ways you want it to alert. From there, you have military encryption, the app encryption, and then Zscaler encryption on top of it. 3 layers. Can run on any network. We have this little demo downstairs of a class device that Eric was so good to build for us. You could put that, could walk into any theater of any adversary, walk into the local AT&T store, go get a 5G chip, some 5Gs of that nation, put it in the class device, you're on the adversary's local telco, they have no idea you're even there because you're completely dark. Managed attribution at its best. Really good stuff. From there, this is what the Zero Trust Exchange is all about. It's about connectivity services, whether you have browser access for your mission partners. You don't control their endpoint, so we're going to do browser access. We'll isolate them as well. Maybe they just need to see data. Again, they can't upload, they can't download. And I can't wait for this to come out because I just saw it in beta. If you take a picture of the screen, it will have the user's name in the image. So if they take a picture from their phone and they try to give it to someone, their name is all over it. I can't wait till that's released. From there, we have the client connector. We have branch connector, or what I call Basecamp Postal Station connector. Cloud connector, you can connect 2 clouds. You could connect C1 to P1 if you want, and if you wanted to do stuff in a zero trust manner. And an SD-WAN, we could write on any SD-WAN. From there, we have a platform services. Again, this is all built in to the cloud in our service, which also, take our cloud, we can install it on-prem. Hey, I have a requirement where I have a group of people, they get disconnected for 5 days, okay, you run in DDoS. Because we can bring our cloud on-prem. It's called private service edges. If your user's there and your app is there, why are you going to go to the cloud and back anyway? Localize that traffic. Same thing like in a backpack, in a Humvee. You're in a campus network that doesn't have, that's what you want to use that for. From there, this is where we do our TLS, break and inspect. This is where we add a lot of machine learning and AI at this level as well. From here, we do device postures, continuous comply to connect. Inside the platform, there's also access control services, DNS, firewall, web, URL filtering, app segmentation, micro segmentation. I don't know if you heard about the Okta piece that they got, one of their internal admin guys used his local Gmail, and they got through Okta again. This tenant restriction would have prevented that from happening, which is here and that. You can, while you're on that network, you only allow what tenants you want access to. From there, we have bandwidth of QoSing. You're on a boat, you're on an airplane, certain things need to go a little bit faster than others, you could do that. Again, having that private service edge, God bless you, sir. And again, adaptive access or continuous comply to connect. From there, we have the security services, cyber protection, IPS, sandboxing. All of this stuff really makes sense. Deception. We place phony cookies on the endpoint. We place phony files and passwords on the endpoint. Now let's just say they go out, and remember that first page I showed you with all of the IP addresses to try to hack you and all that stuff? We place phony S3 buckets. We place phony VPNs. Now that user that had the username and password that he found on his endpoint sells that to someone, China, Russia, whatever. They're using that username and password. We know it's Joe who sold that to them immediately. That's part of the platform. From here, you'll see the browser isolation is in both. For one, for data protection, as well as the browser isolation. When I said, hey, the Elastic had a 0 day on it, we wanted to make it read-only, you get patched, with one click of the mouse, rewrite is now available again. That's in the data protection. We have the endpoint DLP. Someone tries to take a file and download it to OneDrive, it will stop, they'll get a pop-up. You could say, you're being monitored, is this what you really want to do? You can block it completely, or you can allow it. But alert the user that it happened. From there, we could do, what I really like is the CSPM, the SSPM, all of that stuff that's really good, and of course, inline and out-of-band CASB. From there, the connection is allowed to go to the internet or allowed in from your private app so that that tunnel is created. And the next best thing is end-to-end telemetry. From the user's device, what's running on the device. By the way, this is all one single agent for all of this. And the agent runs less than 100 megs of RAM, 160 meg of what you call installation, and less than 1% CPU when it's running at full. So I have telemetry from the user's endpoint to the Zero Trust Exchange, and from the Zero Trust Exchange to wherever that app lives. Private apps, Teams, OneDrive. Ever ask yourself, why didn't Microsoft build their own ZDX? They run Office 365. Because they don't want you to know where they're the problem. The last 3 outages for Microsoft, we told our customers before Microsoft told them. We even told Microsoft what router was down, because we have hop-by-hop telemetry. Imagine calling JRSS, hey, it's this router. So from there, this is what it looks like, just to give you an example. You do your identity and context, you do your risk control, we're still good? Yeah. Enforce policy, your connection is initiated or your connection is accepted. You minimize the attack surface, you prevent lateral movement, you prevent compromise and data loss. From here, when we look at Zero Trust and we look at firewalls, much, much different. Firewalls are pass-through. They prevent compromise, but hey, if I compiled my data after the firewall, which is now what malware and polymorphic and metamorphic pieces of malware are doing, they compile the bad stuff after it passes the firewall. From there, you prevent lateral movement. A VPN's putting you on a network. How is that preventing lateral movement? With Zscaler, there is no lateral movement because you're not on a network. It's just a tunnel to an application that you have access to in this moment of time. From there, the attack surface is completely minimized. Again, no open listener, you can't attack what you can't see. They look the same, right? But as you know, one's all electric running on batteries, the other one's an engine. And when we go into the Zscaler Digital Exchange and we look at it, we understand the endpoint, we understand the network, we understand the app, we do the hop by hop. So when it looks over here, this is what it would look like really quick. And you could see the CEO, you could see the gateway from the hotel had the issue. We could see that right there from the hotel gateway, someone's calling. Now if you start putting in the AI and the machine learning, which the service now has built into it, a instant message can go to that CEO and says, you're in a hotel, your hotel's having problems. They don't even have to call the help desk. This is what this hop-by-hop telemetry can give the help desk to really make it really work well. From here, we understand the device health. We can quickly identify that, hey, we have latency in audio, video, and sharing within Microsoft Teams, and there's some MOS, which I don't remember what that stands for, I apologize, that they're having issues with the Teams. This tells you exactly what's wrong and where it's wrong. All yours.
All right. Thanks, Conrad. Okay, so we're gonna close out with the demo that we talked about in.
You don't need to do that, Nate?
I can do it this way.
Oh, you did that.
So just one kind of critical point. He talked a lot about the just the expandability of and how much traffic Zscaler can handle. So trivia question for you: does everybody have a coin? Do we owe anybody a coin? Okay, because you guys all have earned it. The trivia question is, the name Zscaler actually comes from zenith of scalability. So we have seen an explosion, like, of course, around COVID, when everybody went and started working from home. The cloud that we operate saw like a 1,200% increase in traffic that was coming through. So Conrad had mentioned that we're up to like 330 transactions every day that the cloud is able to handle.
We did more yesterday. We did 375 billion.
Yeah.
It's just growing.
So he's going to just bring up a quick
You want to move your
piece of
laptop?
telemetry.
This, anyone can go to, this is trust.zscaler.us. Yesterday, we did 375.8 billion transactions. Google, what does Google do, 8 billion? What do they do, 8 billion? 9 billion, maybe?
It's a fraction of what
Yeah, it's a fraction of what we're doing. We blocked, yesterday, we enforced 14.3 billion policies. This does not include the federal clouds. This is just commercial, just so you know. We don't publish anything from federal. And threats were blocked yesterday was 186.7 million. Think how fast the AI is learning. Just wanted to show you. So for those of you who did the demo, I got an email. The email looked like this. Well, let's do someone who's not a Zscaler person. Thank you, Eric. We'll do this one right here. And you could see that we had this gentleman send an email. All I did was approve it. If I don't know who this is, I can hit reject there. User gets an email, you're not allowed, or however you want that email to be phrased. And I went in there, so what happened was, I went into ServiceNow and it created the account. This is what, I think this is the one that was that. So you could see it came in. Oh, this is read. So we'll do read instead. Read came in, you saw the approval of the email. If we look at more here, and we look at the emails, you'll see that Read's email came in with the request. See, he came in, this was the email that came in. This was the email that we sent him when it was done. How to log in. So if he does a Splunk, vpnkiller.net. Anybody, vpnkiller, yeah, let's do that. What it's gonna do is it's gonna take me to splunk.vpnkiller.net. It's gonna hit our Zero Trust Exchange. The Zero Trust Exchange is gonna reroute to the IDP. Oh, that's right. I'm using DuckDuckGo. It doesn't work with DuckDuckGo. I apologize. I'm sorry? Oh, yeah, that's right. I don't think it's going to work with DuckDuckGo, SPLUNK, that's it. So now it just took me to my redirect. You see, I went to Microsoft. It logged me in because I was logged in before, and I should be pulling up Splunk. I don't know if you saw the little thing go back and forth, but now I'm going to log in. So here, if I go to Zscaler real quick here, you'll see that Reed is this right here. This is his username and password. If I go here, I don't need this because it's Splunk. You'll see that I'll log in, not now. And now I have access to this application. It could be anything. It could be SharePoint. It could be any application you built just from sending an email. What I want to do is I want to go in, what?
I'm going to wrap up with these slides.
How much longer I got? 2 minutes?
Go ahead.
Yeah, sorry. So from here, I wanted to show you the email came in at 2041. It created the account. Read. Let's go here. It created the account. 9:22 p.m. Sorry, it was created 8:40. Microsoft Azure, read. This was created, I'm sorry, all the time zones are messed up because I'm here in Hawaii. I forgot to change them. And this is at 3:43, and you could see that it came in, read came in at 8:48. Sort of the same thing. You could see the 10 minutes from just the end of the thing that this was created, and we were able to log in to that. All from an approval email that I got. Over to you. Sorry it took so long. It's all right.
So just taking, hopefully this thing will come. So what did we just see? Going back to the coalition or the joint all-domain command and control example, instead of having to build a coalition network, all we need to do in this scenario is build out a coalition application that our coalition partners can get access to. And it doesn't matter what transport mechanism they're doing that. It could be in their home station, they could be sitting on Australian infrastructure and using a zero trust Zscaler solution to get them access to the front door of that coalition application that they need access to. So that's, this cartoon right here is just representing the JADC2 application. You've got different coalition partners. Conrad went over exactly that ServiceNow workflow that was built with that email coming in and that approval being granted. And you saw, you sent in the email, you got the approval, it went through in this scenario, there's some kind of a chop chain there for higher level approvals to all grant access. Conrad ended up just being that general that's sitting there in the corner. And because of, in talking with PACOM, for instance, PACAF, one of the challenges that they brought up was that a lot of these coalition partners don't have an identity for us to federate with, for us to incorporate into a coalition or JADC2 architecture. So what we were doing there is building out that identity repository for coalition partners to be able to get access to that application. And that's what was happening right there. And from an IDP integration standpoint, any SAML 2.0 IDP works perfectly fine for us. Ping, Okta, Azure AD, SAML 2.0, the approval went back. And then in the end, this is kind of breaking down the steps. We don't need to go into a lot of detail. Basically, there's a couple different groups of steps here. You got an approval process, there's an identity that's created, there's zero trust access that's granted, and then the user can log in.
The identity, is that like an Azure AD group, you mean?
Yeah, so that's, yes.
That's what you're talking about.
Yep, yeah, exactly right.
Any attribute you want to use can identify that user if you want, however you want to specify. And if you can have one that should be Azure, another one be Ping, another one be Okta, another one be your homegrown SAML 2.0, it doesn't matter.
Yeah, in DOI, we're moving everything to Azure Cloud, Azure AD.
The demo we did today that I just showed you, that's
Yeah.
Azure. That was Azure or Entra ID now.
And from that email you accepted, that created that AD account?
Yes. The
I was
ServiceNow
amazed,
did
I
it.
was amazed, I never seen nothing like that, that's pretty neat.
ServiceNow did it. We installed a mid server, and that's a mutually authenticated certificate pin, so it's safe to be able to do that within the Microsoft realm. Goes up, creates so we have to create it locally
Right.
and have that same one synced so that it's the same credentials to use for Zscaler as well as local. So it's,
Yeah, you don't want
it's that
conflict.
same, so, exactly, we want that same identity being used everywhere, and that's how we set that up.
So, and
Thanks for the
obviously,
question.
from an operational perspective, the requirements around DDIL becomes really important here. You know, how well without contact with the cloud, without access to the cloud, how well can you operate in that environment? And we have to be able to do that synchronization between both the on-prem and the cloud-based version.
Yeah, we're slowly moving everything off the on-prem to the cloud.
Absolutely, and
We just did
it's the
that
right
with
thing to
all
do.
our MDM too. Like,
Yep.
We moved, we got Intunes, and all our MDM is up in the Azure cloud now too.
Yeah, that's great.
You
So,
can do a continuous comply to connect on Intune with us, just so you know.
if you take anything away from
Yeah,
this
I'm
presentation,
pretty fascinated.
if you're reachable, you're reachable. If we had a merch store, this would be, I think we're making T-shirts. We have T-shirts.
Stickers downstairs, too.
Yeah, we have stickers. If you're reachable, you're breachable. Thank you, Danielle. And I got just enough time for maybe a question or two.
Sorry, I jumped on the question.
That's okay. I understand the
For
excitement.
those of you who didn't get a coin, I got one left, and if you,
I was gonna ask, can I go?
yeah, again, that's the last one, but if you come down to my booth, I didn't realize we were gonna be this popular, so you've come to the booth to say, hey, I was promised a coin, we'll give you one down there. Sorry, I didn't bring it up.
I didn't realize you ran out. So any questions?
No questions?
Website?
Anyone want the presentation?
www.zscaler.com.
If you come, I don't know, I left my cards downstairs, I apologize. You email us, we'll send you the presentation.
I think we have a question.
Yeah, you had a question.
Do you have a solution for a classified environment? for this?
IL6?
Great question. Yeah, so now understand, IL5 to IL6, from a compliance perspective, is not a heavy lift. The problem is finding a sponsor, a government sponsor that would work with us to go ahead and get us moved into an IL6, into the AWS secret region. And so we've done that, working with Special Operations Command. We've got a CRADA with them right now. So they're sponsoring us getting that established. So we're well on our way to getting that IL6 instance, so we can take all of the Zscaler, the Zero Trust Exchange, and put it into IL6.
Great question.
There was another question over here? Yes?
Yeah, just how would this disrupt or not disrupt auditing capabilities?
What was that?
Keeping us in compliance.
You said auditing?
Auditing capabilities. Would this disrupt our ability to do auditing on our transactions across our networks, or would it be non-disruptive? Would it augment?
It would be very disruptive. What we did with CISA, they said, could you please stop sending us data?
But
made it-
disruptive in the sense is you're going to get more logs
Than
than
you
you've
need.
ever
So-
imagined.
What you will need to do is tell us what you want. We'll send it all to you. You can comb through what you think is good for you, and we'll just send that to you. But since we're sitting in the middle, we understand what your IDP is doing, we understand what the endpoint's doing, we understand what the cloud's doing. There's a tremendous amount of data. It really is an actionable in data. I like to call it getting left a boom, right?
a cyber radar, that you can now understand what's happening, real situational awareness, speeding up the OODA loop, where leadership knows where the risk is and can spend to that risk. That's what we're providing. I like to call it a cyber radar, the first one that's been out there.
You know,
I
another,
was gonna say, you want high quality data, you don't just want all the data.
Yeah.
Because then it's all garble and you can't use that.
Amen, brother. Amen.
Own, the data from the get-go, so that we know it's not pared down, it's not manipulated. You know, is there any ownership that could occur within, not our boundary, but within our purview?
yeah, we can package up all the logging data and get it to whatever SIM tool the customer wants it fed into. So that can all be set up so that all that, every transaction is going to be logged, and that all that information can flow right to the customers.
It's true multi-tenant, where it's just your data. We don't even have access. This is why we got our IL5. I think that's where you were really going with this question. We got our IL5 really, really quickly, because when you open a support call, you have to grant us a key. We don't even have a key. It is truly multi-tenant for just you, no one else. And then you can have, root and then sub, and you can have different ones that are set up in there, and then you could do it that way. It's also a true IL5, so when you're home and you need access to something on the Donan, that can be granted. We have that approved through a SNAP request through DISA.
So
We've been tested, we've been vetted, and we were not found wanting.
just within the GRC, governance, risk, and compliance perspective, one of the really cool things about being able to monitor and track every endpoint connecting to every application, you start to build out, from a situational awareness perspective, exactly where all the users are going. And the shadow IT that can be uncovered from that is now you're starting to see exactly where your customers are hitting. And why do I have these customers who work, I'll use kind of a commercial example, but your HR customers that are hitting your finance applications. You could start to see that, and you could start to apply policy against that and get more and more granular on what your users can get access to. So from a GRC perspective, you can now start to apply all of the risk measures that the organization wants to apply, user to application, and start to cut it off. Because it's so hard in the beginning. How do you establish all those policies for every single user to every single application? It could be thousands of applications, tens of thousands of users. So over time, you can start to get more and more granular because you're watching all that traffic flow and you're starting to see it. And it starts to kind of group together in a way that you can start applying policy against it.
Yes, sir, just wanted to, you say you're working on the ATO with Google?
So we have a provisional ATO in IL5 because the organization will do their own ATO. You will take our provisional ATO that we've been granted, and it becomes part of the agency's ATO. On IL6, so that's on IL5, on IL6, what we've done is we've established a CRADA, which is, I forgot exactly what the acronym stands for, but it's a kind of a research and development contract with the government, commercial entity with a government, in order to allow us access to certain government resources. And then in exchange, we're giving our product to the government entity, to the organization. And then there's kind of a mutual benefit there from the commercial product to the commercial company and the government entity. And then we work together. So in this case, we're going to be working together in the CRADA to establish an IL6 zero trust exchange.
We also have a CRADA with H&I, with the Air Force, to build it for the Air Force, and AFRL. I saw AFRL show up before.
Any other questions?
Working with Mark Omar.
Well, again, thank you all very much for
Thank you.
attending. Appreciate your attention.
Come by the booth, sorry, I didn't mean to
Yeah.
interrupt you. We'll send you this presentation if you want it. Thank you.
Thanks.